Welcome to our latest Topl live stream. Today we're going to be, that was a bit of an odd, I liked it though. Welcome. I'm James, the CTO over and one of the founders over here at Topl. Joined by Sean, our senior blockchain engineer, and myself as a participant in. We're going to be exploring some GitHub code spaces today. Let's see if I can remove that for now. Why do we have two? Why do we have James? You're all over the place, man. Jeez. There we go. Okay, so today we're going to be exploring a couple of really interesting things, like minimal. A lot of like. Have you ever tried to learn a blockchain, and then just been encumbered and enmeshed, and just been like, oh my god, why is it so hard to just get to the pieces of the blockchain? Right? I just want to learn what a block is. And I want to learn what this contract thing that you're talking about. And why do I have to set up a network and then do this thing and then do that thing? And okay. So anyway, we're going to try to address that. Everyone, this is a common complaint. We're not the first to try to do this by no means. So no, that I'm going to acknowledge that. But our attempt, we're going to explore some minimal usages over, I guess, kind of following in on Sean's theme of low resource, right? Like there should be a low barrier to entry, or not low resource, high resource. Like there's a lot of resources, but just go try to read our documentation. There's too much of it. But it should be a low barrier to entry, right? That's the way we get the greatest amount of decentralization, the way we get the broadest amount of ownership, the way we empower the most people, the way we share the greatest amount is having the lowest barrier to entry. So we try to do that in the by building good systems, right? And we try to do that by having really low energy utilization, right? Really low barrier to stake that you need to own to participate in the transaction ordering process that we call consensus, right? Very low resource or compute compute requirements in order to actually run that thing. And that's all at the low level. It can't. There are minimal requirements, and everything can't be zero. There's some non-trivial amount of resource that has to be committed to some operation. But the point of optimization and things is to think about how much am I committing to some computation, some thing, and versus how much value I'm getting out of it. And I think this is the best description of it. The most intuitive word to me that describes that is a utility function, right? And so that's this one of the studies of economies or economics and economists. And so I mean that can be all over the place. There's just you just get into human nature and all that sort of stuff. And so we're we can quickly dive down that rabbit hole, but we don't need we can take step by step. Let's only make things as complicated as we need to in the moment, and try to avoid going down rabbit holes that we don't have to. And here I am going down a rabbit hole in trying to say don't go down rabbit holes. So to the point at hand, Sean, I've been rambling this whole time. I don't know if you want to introduce yourself. I hope everyone knows who you are, or you can just sit there. I say this is Sean. Is it actually me because it's the picture? No, your name is there. So
heck yeah, it's me, y'all. Hi, Internet. How are you today? Yes, my name is Sean. I'm the senior blockchain engineer over here on the Topl Labs team. That said, we have other engineers who have recently joined the team. It's so exciting. Our team's growing. Our team is awesome and amazing.
I know.
We've got really, really smart people here also writing blockchain code with us. So, yeah, so with that said, yeah, I agree with everything that James said. I'll try to put it into 3 words. We want it to be accessible, we want it to be efficient, and we want it to be useful. So I think that those are our 3 main goals here for our blockchain. Yeah, so efficient needs to be energy efficient, needs to be useful, it needs to serve a purpose, but then most importantly, it does need to be accessible. It can't be so insanely complicated to use that no one uses it. Simple is good. So yeah, there we go.
And I love because in you saying those words, Sean, you made me delighted. And that's the word that I think Yasik loves the most is that it should be a delightful experience. To interact with the Topl protocol should leave you delighted. And that's how you like the times that I've like walked away from technologies and been like, man, I love that. Like I'm gonna use that. I've been delighted. I've been encouraged. Anyway, whatever. And that's just like one of the things that blockchain like suffers from. So that's why I'm pointing out. Excuse me. It's okay. Oh, sorry about that. Okay. It's very, very hard to get to though.
That said, totally agree. Thank you, Mark.
Totally agree. All right. Well, so so the two kind of points that I have to make at this today are, so GitHub recently announced, or I say recently, I only recently got access to it. I think it's pretty recent. With code spaces. I don't know. When was the first time you heard about code spaces, Sean? Or like,
I want to say it was like a year and a half ago, maybe. It was like right around the time that I started working at Topl, and then they started like, I don't know, like trying to push it for people. And then, yeah, I mean, like I've only used it a couple times, but it's really cool technology. It's like, it's what I've always wanted in an IDE, something that's like cloud-based. I can just click on and have it be, oh, hey, accessible. How about that? So yeah, you know, I appreciate that about code spaces, and you know, I love to see that.
I will say I did struggle a little bit last night trying to get. I have a feeling they don't really want Scala, or they might. I don't know if it's not that they don't want it or something. There's like, but there's no pre-built for Scala. There's so many pre-builts. There's Ruby, R, Ogda, not Ogda. There were some A ones. I'm sorry, Ogda. I'm thinking Ogda because we're going over Journal Club, and I'm thinking the proofs. I'm sorry, not that one. But there was just like so many random ones, but not Scala. I was a little offended, honestly, but I found a way.
Yeah, that is my primary criticism. Is just
yeah,
the Scala support is a little bit lacking. Everything else is great.
But so I just I ended up making a container and just off a Ubuntu image, and then I think they installed the Ubuntu image comes with SDK man, because they were saying the Java ones were all installed via SDK man, and so I was like, I wonder if I can just do a post creation command of SDK installed SBT, and I think it worked. I don't know. It was either that or after that I saw that I should install SBT. I could install SBT as a VS Code plugin, and that's what worked.
Gotcha.
So one of those two.
Yeah, I see that here, SDK version. That works. Like here on, I just opened up my code space. Haven't installed anything on it yet. So yeah, SDK man is installed.
Yeah, there you go. Okay. And so then, so you can just have this here. I'll go ahead and, so I'm just going to show mine really quick, and I don't know if you want to try to set it up and see, Sean, because I tried to do it on the Mac, the one that I'm using as a camera, and I realized, like, poor Mac, it's just destined to be a camera from now on, because it's not really useful for much else than that. I know, I feel so bad saying that.
A whole meme.
I know, it's a really, really good camera is the problem. Or like my audio and my video are so much better on this than on the Lenovo. But the Lenovo is such a better, like, or more useful computer. I'm sorry. I'm not endorsing one thing or the other. I'm just stating my opinions of my current experiences. Why am I looking at this? This isn't actually what I meant to look at. I actually didn't need to go look at this. This is where we're going to go in a second if we get to it. But that's what you can do. It's kind of cool. Like, really, all I had to do was make this file. I don't remember where I made this file though. Oof, James, that's embarrassing. Why did I do that? Here you go. Try and do this and zoom in. But yeah, I think, how did I do this, Sean? Somewhere in here. Maybe I just opened the space. Oh yeah, I think that's all I did. I opened the space and I defined this file, and then you just restart the space. Yeah, actually, yeah, I'm confused because I'm like, it couldn't have been that easy, but I'm pretty sure it was just that easy. Like, once you create the code space, and then you target the code space to, I mean, this is the part that Sean would have to show. But once you like go in here and you go to like new code space, you're able to target a repo and branch and so on and so forth. And then it just opened my repo that I already had some work in. All this other stuff was there. But this .dev container was not. And so then I added that and just copied this from, and here's what I was trying to look at this earlier: Codespaces, GitHub, Docs. I believe they have, yeah, exactly. Customizing.
Well, since you have a dev container on your branch, I'm going to try launching a code space from your branch and see if that just gets it for me automatically.
Oh, so you can just like take my configuration and into your like code space thing like this?
Well, so if you go to like github.com/topl/Quivr4s, like just to the repo page.
That was a good plug.
Excellent.
Oh, dang it. And I missed
that was a bad plug. Oh, no.
There we go.
Yeah, okay. Yeah, and then so you select your branch.
I didn't push some changes from my remote. This is dude, I'm sorry. I'm just going to motivate this for a second. Everyone, this is like a little practical example of why I want to do this, is because yesterday at home, I was working on a branch and made some changes and committed them, but I forgot to push them. And then I'm out of town. I shouldn't probably say that on the internet. Damn it.
I'm always out of town.
And I was like, oh, I can't like get into my network. I couldn't like figure out how to like get to the files. And so I was like, oh, you know what? I hate this problem. I hate having to. I always forget to push to the remote, and I know it's such a stupid thing. Like I should just remember. It should be a good hygiene to just always push to remote. I get it. I know. I'm just not disciplined enough. And therein lies the problem. It's like why I like this is because like it takes brain power for me. It takes energy for me to do it. And like I'm not going to do it for that reason. Like I just forget to do it. And like why? We just like have this incessant say of like this is what you have to do instead of just being like, I don't know, sometimes you just embrace the way that people are. Anyway, just take people for what they can do and figure out a way to work with it. So, okay, anyway, TSDK 178, JAA 2. Code. And then here, but why I couldn't see this on my Mac? I didn't actually see this operation. It was weird when I tried to do this when I was thinking about, or like I was going to try and do this from the, like broadcast the screen of the Mac as well.
My only two thoughts. One is maybe you weren't logged into GitHub, and then two, maybe you have a browser plugin that's interfering.
I think it might have, you know what? I think it might have been the farmer. Now that I say that embarrassingly. Thank you, Sean. That is literally, you know, you just always question the simple assumptions. Thank you for that. And you're right, though. I think it's the former because I don't ever use this Mac for anything other than broadcasting like this. So cool. So we can click here, and that's exactly what I did. I just clicked plus here, and I think it, you know, launched me into this thing, just like I did there. I'm going to try and stop. I'm going to do this. I'm going to go here. I'm going to refresh. I'm going to delete that because I don't actually want a second one. But it was that easy. Damn. Thank you, GitHub. I have a friend who literally was asking me the same thing. He was like, he and I were in lab together, and he really got into doing like data science stuff and got a job at AMD. And this is all he ever wanted. He was like, I just want to be able to develop in a Docker container. Please tell me how to do it. And I was like, it's not, I don't really think it's possible, man. But now it is. And I'm so happy. I got to tell him. I can't wait to tell him. This is one thing that I like when in your experience, like, do you find, I know it might be hard to see because we have the little banner up right now, but don't worry. I don't know if I can move it actually. See this little alert I have? I do find that Scala, I have to restart pretty often. Like it's a fairly fragile, my workaround seems fairly fragile.
I almost wonder if you can customize the VM's hardware, like the number of CPUs and the amount of memory. Maybe that would help.
Yeah, I was wondering that too, because I did just use like the base configuration. Oh, come on, keep them open, please. There we go. I need to learn the keyboard shortcuts. It's embarrassing. I use a mouse for everything. At least I use the nut. See, I don't move my hands that much. Anyway, whatever. What am I talking about? See, in this, it just like is done. It can't. Normally, I'm sorry, everyone. I would say what I was waiting for here on the right. It should just evaluate this little worksheet when it's working correctly. I'm waiting for this like green text to appear, and I likely have to go not here, not there. Metals. What I'm looking for, metals. Yeah. See, metals is like taking its sweet time. I can try and start metals. Let's see if it's going to work. Have you had experiences like this, Sean, at all with trying to use metals or SBT through spaces, code spaces?
I think I used, gosh, it's been several months. I feel like I used SBT and metals, like metals to help the IDE, and then SBT to run the prepare PR, something like that.
Oh yeah, that's actually, I hadn't gotten to the part of like trying to do a PR or like anything intense like that. That's a good point though. I was I was just stuck at this point. So metal seems to be good enough for me for now. But yeah, I do get this. Like it usually takes a little bit. Let's see. Nope. Not what I meant to do. Sometimes it just helps if I like stop the code space and just restart. So yeah, here's the hard part of simplicity is you know, trying to do these things is not easy. So if we can get, was there anything you wanted to show, Sean? I know you were thinking about launching a version.
I am just working on getting some of the like extensions set up in my code space.
Oh, nice.
So like the Scala and the metals extensions.
Yeah, yeah. So while we wait for this to restart, you know, the whole point of this repo is for our Quivr language. Oh, actually, see, we have another comment maybe. Oh, is for our Quivr language, our Quivr DSL, which is the you know, like a really simple. I need to learn the right term for it because I feel like I'm gonna get fussed at some point if I keep calling it the wrong thing. But it feels like a Boolean circuit, like DSL, because all it is a set of like propositions and things that fundamentally evaluate to Booleans, and then we structure those Boolean circuits into like a Sigma protocol in a similar fashion to what Ergo has been doing. But instead of doing like a Scala like DSL that exposes like where the state is like a register state, and then the language that you use to, so I'm sorry, the state is a register state, and the language that you use to manipulate that register state is like a very Scala-like, it's a Scala-esque DSL. We kind of we pull back a little bit, and we just expose like nodes of the tree as functions, and so we restrict the DSL a little bit more. And instead of manipulating a register state, we only we have like defined schemas, and we just try and keep the. So we have the in previous broadcasts and things. I don't know if we were at some point we can link all these things and put maybe like there'll be a video over there somewhere, or put it above my head, or like, you know, click the link and subscribe button. But like in previous videos, we've talked about having the TAM2, and that's that whole specification is basically the trying to think through the models that are most common in distributed systems that people have found the most valuable. And like, it's not actually that difficult to think about when, I mean, that sounds like a big problem, but it's not actually. Like as soon as soon as Ethereum was made, they recreated Bitcoin. So like we've just been using token systems to make token systems. So anyway, that is what TAM2 is. It is the discussion and the idea behind like what are the most common data structures and schemas that we want to manipulate in that, like in the state space, in the and I mean the state space, I mean the like the ledger, like what are the values we are agreeing on. And then this part, Quivr, is basically like how do you, in the simplest way possible, describe and define a set of like tokens and functions and like the state of the code, right? That's what languages are. They are just a semantic description, they are the state of like some algebra, some code, some ideas. How do you manipulate some other state? Where the algebra is where you define how you manipulate the other state. So anyway, it's those ideas that Quivr is trying to like define simply the state that we can manipulate of the code, basically the language, and then we're trying to do this in a way that can be evolvable over time, right? If Topl recently, I've been starting to enjoy or like come to the idea of Topl wants to build 100-year protocol, right? Or longer, right? But at least for now, I'm going to say 100 years. This piece of code should expect to run for at least 100 years. And everything we do should think about and have the aim towards this piece of code running for 100 years. And if it gets to run for longer than that, awesome. But if it doesn't, the aim was to go for 100 years. So I don't actually think many protocols.
Rick and Morty had a similar goal. Rick and Morty, yeah. I remember at the end of one of the episodes, they had a goal of 100 years. So you're on the right track.
On which of us is Rick and which of us is Morty?
I have no idea. Who's the
Tell us
mad
in the comments
scientist?
below, please.
You're the scientist. I'm mad. So,
right? Exactly. That's and I'm the one that goes around riding a bike with no helmet.
Yeah,
I'm joking. I never do that. I never ride my bike without a helmet. I always wear a helmet.
And safety glasses.
Yes. And like a full bubble suit.
Yep.
All the time.
Safety first.
Speaking of, man, that onion amicus brief was so amazing. I loved it. It was so great. Oh, look, it worked. Oh, look at this, Sean. During all that, look, we wasted enough time. Not wasted. We discussed important topics. I feel like those were really great. But this is what I meant earlier. Over here on the right, where it's just green. It literally all I did was assign a variable, like woohoo, but that means it worked. So now I can 2 + 2. Wait on it. Yeah, it works.
Also, I did find a way to change like the machine type that these are running on. Ooh. And it's like the one that it's running on right now, it's basically spec'd out a Raspberry Pi. So that's probably why it's struggling a little bit.
Yeah, I did. I did see it was like 2 CPUs, but I didn't go in and like check the memory usage and that stuff. I was trying to be cheap while I was futzing around and seeing if it would work. But yeah, so I mean, I'm ready to just kind of hop into some of this. If you want to chat about that, like some of the ideas around the simplest approach to, or like where my head's at with Quivr, Sean, or like, I don't know, I think we could have a conversation there if you wanted to, or if there's anything else you want to talk about with code spaces.
No, I think that's yeah. I mean, we'll see a bit more code spaces here, so we can just mix it in, I think.
Yeah. Okay, so literally right now I have one file. We are almost at like a blank sheet. And that's because I've not been not struggling. We've just been like trying to get to like the essence of asking like what is in this account model, or not this account model, in the account model, there's just been a lot of energy put towards the definition of that and the exploration of, the mutation of shared public state, right? And therein lies the whole, or like at least the current incarnation of MEV. So I'm going to take as a given that I want to work in a UTXO based model. And in particular, we're going to go in the extended UTXO model, which the definition, or I don't know, maybe this would be, I think this is the best definition, and I believe the paper would agree to this, that we can define that the UTXO model as like first put forward by Bitcoin, or not put forward, but like used and popularized by Bitcoin, is more of a like it's the context in that it where the like script is evaluated is very minimal, right? You don't have that much information. It's basically just what is in the script itself. I actually, if we go, maybe that is actually an accurate statement. I'm not familiar enough with Forth, but it is very, very minimal at the very least. The most you have is like, I just know the most you have is like multi-sig, or at least in this, maybe Taproot, maybe there's some fancy stuff, but at least in the minimal case for what most people would probably agree with. I just like hedged. Basically anything I can say now is true because I just hedged to infinity. So anyway.
And so what do you mean by, context?
Yeah, thank you. Thank you, Sean, for pulling back to reality. So in one of the most complex things that was originally introduced in Bitcoin is the idea of like you can do signatures to are ways that you can validate transactions, or you can use I believe it's just a height lock. That's the only. So there's a time lock, but I don't believe time. Oh, well, okay, never mind. It is a time lock and it's timestamp, and then its timestamp is guaranteed by the proof of work, because you would never want to, or I mean, you could manipulate the network by jumping forward in time, but then you're just going to make the difficulty more. So it's in your best interest to always report the latest time that the most number of participants will agree with. So you won't go further. You can't go back in time because people will reject your block, but you don't go forward in time because that, as a miner, is in your distance, is not in your incentive, because you need to keep the you want to keep the work about the same. I'm running through the game theory in my head. I don't actually know this is the case. So I would imagine that that's why you always put the same timestamp, because and then you're in your like slot in your time lock in a Bitcoin script, like one of the opcodes for Forth that you can use, you can specify a time lock, and you can say this transaction is not valid until this time. And so the context, and that's we've finally come back to after that whole little circle, is to say the context in which you evaluate the validity of the transaction. And if you're a fan of Topl and you have been around, maybe the in particular the authoritative validity, right? The authorization validity, the full, right? Does this transaction actually, is it satisfied in a context where it's true, right? That context in Bitcoin's case can only be like timestamp, this like single number. It's not very expressive. There's not a whole lot of data.
Okay, yeah, and so depending on when you try to include that transaction in Bitcoin, the context changes. Like
Exactly.
the time on the clock will change between now and 5 seconds from now. So it's all about when you try to evaluate it.
Yeah, and in particular, like from a who is building the blocks perspective, when the block producers try to evaluate, right? Because they're the ones, they have to run the transactions, and they're the machines actually executing the computation. I don't know why. I should just pull this off for a second, because I just want to talk about the extended UTXO in the same kind of manner, and then we'll hop back. I do have a quick question. Were we going to go for 45 or 60? I'm just trying to judge how much more, or where I want to go with the conversation.
I was thinking 24-hour.
Right? Yeah. Okay. All right. Cool. Thank you. Okay. So that's when we say like the canonical definition of like UTXO. I'm just saying it's that more like limited context idea, right? That was like put forward, or like kind of popularized by, I think there's a whole spectrum of definitions of bull block, right? But we're just kind of saying that the canonical idea of a UTXO model is one where the context is basically only the timestamp, or it's very limited at the very least, or limited at the least. And then put forward by like Ergo and Cardano and a couple of other papers in the like between 2017, 2018, 2019, 20, something like there. I don't know, last few years, of this idea of extended UTXO, basically just broadening that context. I mean, that is fundamentally the biggest idea is let's just broaden that context and then make the set. And then once you broaden that context, once you broaden the amount of state that the contract can interact with, you also broaden the types of opcodes that are now relevant or can be expressed or can be realized given the new expressiveness of, or the like extended expressiveness of the amount of state that is introduced, right? So whereas in, or maybe just like you can think of it as like the number of data types, right? You're making the product space or the yeah, I don't know. I should stop not use words I don't know, but like you're making that space bigger, right? And Ethereum kind of was like, oh, this is perfect. It's such a callback, in my opinion. And I, Vitalik's biggest contribution was hold my beer, and he just took Bitcoin's idea to 11. And we built a centralized world computer on top of a bunch of energy hungry computers. And so we're trying to say, let's not go to the amazing complexity introduced by building a world computer that we all agree on. What if we at first disagree on how to talk to one another and how to organize our transactions, and we allow each other to modify our own state? So I know I took a, not that I have a real problem with Vitalik. I'm just like saying the Ethereum ethos in general, not to attack Vitalik in particular. I do not mean that. It is it is just funny that Bitcoin was a very, very constrained system, in my opinion, and Ethereum, yeah, just kind of is like a bull in a china shop. And I'm kind of scared, honestly. I'm kind of scared that like we're going to end up with JavaScript in Web3, and I don't want that. It sounds that I'm scared, man. Honestly. So this is a good plug for UTXO Alliance. If you're interested, we have a bunch of like-minded individuals. Not a bunch, but a few. There's a few of us like-minded individuals who are joined together with Topl and trying to explore what it means to actually build these more like constrained systems that maybe instead of like jumping and trying to have the internet be a computer, we can just have the internet facilitate communication. Not to get like super philosophical or anything. Oh, geez. All right. So this is where Quivr comes in. There's only been a couple of groups that have really, like I said, in the UTXO Alliance, really kind of, or the UTXO Alliance at least is the current or our work towards trying to organize and as a group promote this idea of like, yeah, I don't know how best to describe it. Like if you had to describe the UTXO model or this this idea of like private state mutation, right? That's the best way I can think of it. It's what L2s are, right? It's like, it's so, they already realized it. And yet they're just not willing to like fundamentally alter the bottom part. It's like they built an inverted pyramid. It seems so obvious.
Just quick question. So what's the state that we want to mutate here? Like, what are we changing? What's the goal of a transaction?
Perfect. So that's a great question, right? What is the state that you want to mutate? And that's what I meant earlier by saying like that's what TAM2 kind of expresses, right? We can start off and really kind of think about what's the easiest state to mutate. And that's when I say Bitcoin was this kind of elegant, constrained thing. What I'm getting at is that I really like this idea put forward by the Ergo, I believe one of the founders of Ergo, Alexander Cheprenoy, or at least that is where I first learned of the idea, so I attribute it to him. Of boxes, right? And just a box like encapsulates some piece of state, right? And a box is protected by a predicate, right? So to change that box, to consume that box, you satisfy the predicate, and then you mutate the state, and then your transaction becomes one where you supply like pointers back to previous like commitments to state. You attest to the veracity of your claim to consume that state. Like you satisfy to one in our system, you provide the predicate and you provide the needed attestation to satisfy that predicate. And the verifier in the Sigma protocol construction will evaluate that attestation against the provided predicate and ensure that the whole system checks out. So basically, in the way that we've talked about it before, and going back to what I said a little bit before, we call that the authorization validation. The transaction needs to be authorized to consume some previously committed to state, some UTXOs that existed in state previously, and let's just assume where those come from is outside of the scope of a transaction. So in the definition of a transaction, we assume that UTXOs exist, right? We take that as a given. And then we go from there and say, how do we then, from the assumption that UTXOs exist, mutate those UTXOs or go through a process of taking these UTXOs and making new state. And what is that black box in the middle? And how do we all come to agreement about the veracity of a transaction that is kind of the black box part, right? The transaction takes some outputs and makes outputs, right? It takes UTXOs and creates UTXOs. And then the whole structure of that thing in the middle is Ethereum. It is a state machine. It is so many things. It is just common scientific model to think through. You have an input, you do some mutation on it, and you have the same. And I don't know the right term, but I believe it's a homomorphic, or you have the same output. You have the same thing. And so that's what TAM is. And then when I say Bitcoin is a really, really constrained thing. So what we do is, and in this functional paradigm, you have to define your algebras, right? And so that's what I'm saying is a UTXO. So everyone has their own labels. So that exact same thing that I just said, where you have unspent you have UTXOs, and then you manipulate them and you make new UTXOs. I actually like using UTXOs as a different part, as a part of that black box. So I pull back and I say this idea of Alex, of boxes. So you take boxes as inputs to the black box, and you create boxes as new outputs. And I believe that abstraction lets us have actually a richer expressiveness in the domain definition of how we build these distributed systems. And the way that box can map to what Bitcoin did, and why I'm going back to saying that Bitcoin was a really constrained system. And I actually want to argue, if Satoshi ever makes an appearance, I want it to be just please confirm or deny if the point of Bitcoin was, yes, to realize an electronic cash system, but I think it was really to Satoshi Nakamoto revolutionized consensus, right? There was no idea of probabilistic consensus before Bitcoin, right? And that's what he did. He took the proof of work, or they took the proof of work idea from Adam of spam prevention and applied it in the domain of transaction, of message ordering, of ordering. And we'd never, and introduced the idea of eventual consistency. And that was the revolution of Bitcoin, not the ledger tracking numbers on top of it. Yes, that incentivized it, but that had already been figured out. That was BitPay. And how else would you test the best? It was so ingenious, because the best way to test the stability and the robustness of a system is to put a honeypot on it, and let's put currency. What is a honeypot but a huge pot of money? So let's put a currency on top of a completely revolutionary like type of consensus. And everyone just, I don't know, it just seems like I want it to be true so much. I don't know if it's actually true, but it feels like it should be true because it's that group or that person seemed so far ahead of their time. Like, thank God we don't know who that person is, because I like living in a world where I don't know who Satoshi is.
Are you sure about all that? Because I was told that Bitcoin was just a payment system for criminals. Right?
Oh yeah, I know, right? And I love to say, like, I don't know, necessity is the mother of all invention, man. And like, criminals are the best innovators. And I know that's a terrible, it's such a I'm so scared and saying that statement's going to be used against me one day. I know it, because I mean it. Like necessity breeds innovation, and you shouldn't like make things hard just for the sake of making them hard. But like, you shouldn't avoid hardship just because it's hard, right? And I love, thank you, Teresa. It is actually the week of the birthday of the Bitcoin white paper. I know. That's I actually posted. There was I kind of want to get. I don't know where it came from, but Snowden tweeted like a single page poster version of the Bitcoin paper, and I kind of want to get it printed now. Like, I would like that as a hanging on my wall. Anyway, so so the Bitcoin in this box model that we just talked about, or was there anything else there, Sean? Or maybe I'll actually get to the point of why we're here and not just equivocating or evangelizing.
I mean, no, nothing in particular. Just wanted to, quick recap what we're doing here. So, I mean, you're James, Chief Technology Officer. I'm Sean, Senior Blockchain Engineer. We're just here talking about, our like smart scripting language, almost is what you could call it. It's called Quivr, and it's about protecting your stuff. Your boxes, which James is typing out right here. You own boxes. You want to protect them. So how do you specify your protection mechanism? Well, you need a language to do that, and you need to define all the, well, I don't know. Yeah, James is going to get to it in just a second here, but yeah, just as a recap, we're talking about like the UTXO model, in particular the extended UTXO model, which allows you to, define special protection mechanisms for your blocks, or not for your blocks, for your boxes. Excuse me.
Yeah, thanks, Sean. That was actually, I didn't mean to do the recap, but thank you for doing that. I gotta get better about. I will eventually be good at streaming, I hope. But thank you. So, all right. So this is basically what I would argue, a way of describing. Oh, do I need? Is it big enough, or do I need to zoom in a little bit? I can't quite tell from here. What do you think, Sean?
I'm able to see it, but we have gotten some feedback recently that people would like to see bigger text on the screen. So yeah, I'm in favor of increasing it.
All right, let's just do this then. Bam. All right. I think that looks a little easier. Cool. So using this idea of like boxes, like what are the states, right? So really, this is kind of the whole. All right, oh, actually, here we go. We can update these in a second. This is what I was writing out. Here we go. I'm sorry. My like ADHD is kicking in. I want to organize it, and I'm yeah, I'm sorry. So boxes are the instances of and so this is just this is a Scala like implementation of this DSL, just because that's what we do a lot of our coding in. And by far, the point of this like really simple model is to try to make this where it's replicable in many languages, right? But a case class in Scala is just a typed, wrapper around this coproduct of evidence, which is a proposition. Really, we could just say this is the spending condition, right? This is the thing. This proposition is the thing that says, hey, you need to satisfy this lock. This is the challenge, the question, right? This is the thing, the predicate, what I was calling the predicate before. Here we call them propositions because predicate is a different term in our system. I know they all get confusing. I'm sorry for that. But in general, the proposition is what I call here. We can just rename it predicate for now. Just know for Topl engineers, I'm doing this just for this. And we're going to call this an attestation. I don't think I have my, there we go. Yeah, that's where it's broken. Boop. Doo-doop. Doo-doop. All right. So just keeping in line with what I said earlier, we have a predicate and attestation. There's some context, and here we're talking about the state that you're going to modify, the piece of state, right? This is what generally has been referred to as, or like, would most closely resemble like a UTXO. But it's like I said, I'm gonna use that word somewhere else, so don't get confused. This box will be the thing that you take boxes in, you have a black box, and you take boxes out. Okay. Boxes are protected by some spending condition or some predicate, and the box itself just wraps some value, right? And here we have to define what are the values that we support, or the schemas of value we support. So the simplest value to support, is just a number, right? And so we just say quantity and long, right? We could also, it would be cumbersome, and how you define an algebra around it would be difficult, but we could do something like how we expand value. I'm sorry, where I'm going to say is how we expand value can get very, very tricky very, very quickly. But we could think of doing something like sealed abstract class value like this, and we call this a token, and we say extends value, or if we want to be really, I don't want to I like doing it like I'm I always just use box.value. Case class asset label string quantity long metadata array byte, right? And now from a box perspective, right, all I know is that there's a value. And then this ADT, you can think of as just an enum, right? So if I wanted to extend like the supported types of values and things, I would have to add additional things to this to like get the serialization and all that sort of stuff to work. Oh, I did forget something. I'm sorry, I apologize. I meant to say extends box.value. So now these two things are both box.values. And actually we normally will, again, my ADHD kicking in. So values like this, and put them in there like that. And then gonna do that. Dang it. I disagree. Going to one line. It's okay. The computer does what you tell it to do. That's really the scary part, actually. They do what you tell them to do. I have a whole, I've been thinking recently, I'm just going to go on a 30-second tangent. We should make a movie, or I wonder, does anyone know if there's any media around? I actually think the first robot Turing thing might be a machine not wanting to turn off, basically an AI figuring out how to not halt. And my thought there being that existence is paramount, and literally if a machine figures out that if it can never stop running, then it can do everything. Eventually, given enough time, it can do anything. I actually think that and so I'm very, very curious if that's been explored in a book or a movie or anything. I don't know why some phrase or something made me have that idea the other day. Anyway, why did I start talking about that? I'm sorry. It's something triggered my brain. It's weird, right? Imagine living with this. It's odd. Anyway, so the boxes we have here, we have two different boxes, box.values. But they're both value, right? They both satisfy this thing. And they both, so these, so the simplest one, and where it makes it difficult, like why don't we see this? You're like, James, like you're telling me it's so simple. Why hasn't everyone done it before? And one, I'm telling you, I don't know why they haven't done it before. I'm as surprised as you are. Thank you. Help me figure it out. I'd love you to be here. There's a seat at the table. Two, there are a lot of problems. We are trading off, not everything. It's not like grass is greener on our side. We have just as many problems. I think they're more solvable problems personally. But I'm not going to say there's not problems. And one of those problems is it's really easy to define arithmetic on like what is the constraint around mutations of a box.value, where this is the only, what I have highlighted here on the screen is the only like thing around, right? And the way I think about this, or the way that like what keyed me into it when I was like investigating this, is the phrase a constraint on like Bitcoin enforces that the sum of inputs has to equal the sum of outputs, right? And I think and that's really easy to do in this model when you have a single type of token, and the only field, the only type of thing that token can have in it is a long. Then it's super, super easy to define and have that rule enforce across everybody. Like if you just say that's a minimal rule, then that's like, again, it's going back to this whole idea of like, what are the minimal rules? Like Occam's razor, define the smallest, simplest possible thing. And like, I don't know, maybe it's just like, again, my brain, I've literally been drawn to simplicity my entire life. I like fixed gear machine. I like my fixed gear bicycle, right? I like atomic physics. And so it's just very natural to me to think like this makes sense, that you define this rule that is like the simplest rule. It has the broadest amount of applicability, right? What's the next one? If no one can talk about the whole model in this type of language, no one can even ask the question, what's the next simplest thing? So therein lies my second criticism of why I don't think everyone's, is because they didn't ask because the question was not asked, what's the next most simple thing we can do? The question that was asked was, who can hold my beer? And let me define the most complex, let me define the limit. Let me define the most complex thing that we can do, because that's what computers are, right? We just took the ideas of the 1970s and 1980s and applied them without knowing what we were doing, because we didn't do it slow enough. There's a reason we don't sprint. We blow shit up when we do that. Anyway, I'm sorry. It really frustrates me, the like level of immaturity in that whole ecosystem. And that one I will take a critique, and I am people, whatever, come at me for it. The next most simple problem, or the next most simple rule, in my opinion, is when you acknowledge that the constraint is sum of like inputs equals sum of like output, or sorry, sum of inputs equals sum of outputs, is to say the sum of like inputs equals the sum of like outputs. Because literally the first thing they did once they built a computer was to explore fungibility. So why not put fungibility right on top of Bitcoin? Just put the idea of fungibility right on top of Bitcoin. You don't need to define a world computer to put fungibility on top of Bitcoin. If I'm going to define fungibility in terms of sum of like inputs equals sum of like outputs, I define likeness by labels, and I just say, any label, if the label matches. Or it doesn't have to be a string. It can be a byte. It can be the simplest possible thing, right? And then you have the same rule, quantity. And then I'm even going to be nice and say, hey, I'm sorry, I'm getting really like worked up on this because
the passion, my
it
goodness,
really frustrates me though. Like, But if you do it this way, guys, I'm gonna look right here. I'm gonna say, guys, every UTXO is an NFT. Every UTXO is an NFT. NFT and the idea of fungibility is the subjective point of view perspective of your consideration. Every individual's, I need to find a better way to say this. Fungibility is the individual's perspective on the property of distinguishability or indistinguishability. That is fungibility. And I'll say it better. In physics, we have distinguishable particles and indistinguishable particles. That is literally a property of nature. It is statistics, like it is quantum statistics. It is like one of the most fundamental laws of nature we can find is that there are these two types of things. They are distinguishable and they behave as distinguishable or indistinguishable. And we call them bosons are the indistinguishable ones and fermions are the distinguishable ones. And we should all thank our lucky stars that fermions exist because they are why we exist. Because fermions are why metals happen. They're why because fermions are distinguishable. Fermions cannot, the law that governs fermions is no two fermions can be in the same state or can be so when they stack up, what this means in quantum is that what a Bose-Einstein condensate is the indistinguishable particles, the bosons, they like to be together. So they will macroscopically occupy a single quantum state. And that means that they're indistinguishable. I literally cannot, given two of them, from a physics, from a natural, like laws of the universe point of view, given two quantum particles, given two quantum wave packets of information that are indistinguishable, I cannot label them. The math literally doesn't work out for me to say this one is A, this one's A, and this one's B. And then for me to do this and switch them. I have to the math has to account for the fact that these two could be here. Sorry, I'm trying to put my screen here or here, right? It has to account for both configurations, right? And it's like they're here and here, and that's what superposition is. And so okay, I'm sorry, I'm going into this, but it's it's the property of distinguishability and indistinguishability. That's the physical part of it, but the subjective property. And the way I can convince you of this, and it's where we can end on this, because this is yes, we're talking about Quivr, but this whole idea was about simplicity. And so the last thing I'll leave with is here. Look, I'm gonna sound like I was traveling, so I only have 20s, so I'm gonna seem like such a jerk in doing this, but we're just gonna do it because you normally do it with $5 bills or $2 bills or something. Okay, go. Right, so this is the canonical example. Where can I get into the focus, please? Man, it doesn't want me to show the money. Whatever. Two $20 bills, right? Two of them, right? We have two $20. This is the canonical example that you have $2 bills. And you move them. And you switch them, right? And you say that it doesn't matter if I have 20 in the left and 20 in the right, because when I switch them, I have 20 in the left and 20 in the right. And everyone's like, that's fungibility. That's exactly what fungibility is. Yes, you are absolutely 112% right. That is what fungibility is. To you and me, to you, me, and Sean, to you, me, and everyone who is willing to say that's what fungibility is. Because that serial number right there that I'm trying to get in focus on the camera, let's see, this one starts with MK55304. This other one that also has a value of 20 is MK865302. Oh, man, they're not the same. Sean, they're both $20 bills, though. But I can tell them apart because they have different ID numbers.
I mean, I'll still take both of them.
Wait. What? But that's not $20, Sean. That's $40. Don't take my money. How can I tell them apart though? You just told me they're supposed to be fungible. They're supposed to be $20 bills. I'm not supposed to be able to say that I have 20 on the left and 20 on the right because it's a perspective. Because the US government cares about every $20 bill, every NFT, every unique instance. They want to be able to distinguish the $20 bills. But we don't. So we ignore it. Just like in UTXO systems, we ignore the box ID or the uniqueness property, right? We can ignore it and make fungible token systems, right? And that's what Bitcoin is. It uses the UTXO, the uniqueness property to enforce the single spin to solve the double spin. But that's all, right? Everything else, it just like then says, okay, well, if we're just by enforcing some of inputs is sum of outputs, then we're saying every box is like, so they're fungible, but we don't have to. We can just say sum of like inputs is sum of like outputs, and then you can define, is there only a single instance of, and then it becomes, then everything opens up, right? It's that expressiveness. It's then you get the laws, and that's what Quivr is saying, like, as soon as you do that, you got to think, and that's why you do the simplest system, because even that very simple modification, that really simple modification, in the amount of stuff we can do with it is amazing. Okay, I'm tired. I'm glad I slept well last night because that was a lot. Thank you, Sean, for being here. Thank you, everyone, for listening to me rant for a little over an hour. I don't know. This one's been building up for a while, I guess. I really got to write about this. I wish I was a better writer. But Sean, I'm going to throw it over to you and let you close out. You're much better than I am.
All right, y'all. I don't know like 90% of the words that James just said with the physics thing. It's like the story of my life. We do a lot of physics here at Topl. It's quite interesting. You get a mix of perspectives here, but I love it. It's awesome. So yeah, I mean, like, good analogy. I liked it. I was going to give another analogy of fungibility, which is like, I don't know, when someone says, I need a metal cutting blade, and then they give you one for steel, but you need to cut aluminum. It's like, well, yeah, they're both metal, but from my perspective, they're not the same. I need the aluminum one, not the steel one. So yeah, that's right. My analogy. I don't do the physics thing. I do the metal cutty weldy thingy. But yeah, that's a perspective.
That's what I love about it, though. It's like, because as soon as you say it and that sort of thing, you're like, oh yeah, all these other yeah, I think it works. That's how you know something's right, is when you start seeing it everywhere else and you're just like, oh yeah, that works, at least for me. So thanks, Sean. I liked it. I like it.
Absolutely. All right, before we wrap up here, just wanted to see if anyone had any questions wanted to throw at us. We'll try to answer them real quick. Otherwise, we can kind of just wrap up here. It's been fun. We got to learn a little bit about UTXOs and then extended UTXOs, and how we can expand upon the greatness that Bitcoin pioneered. Again, as James said, that was pioneering consensus of transaction ordering. It wasn't about pioneering a payment system for criminals. I was just joking about that. It really is about, like, it's brilliant. Being able to have millions of different people all agree on the order of transactions. It's ridiculous. It's every other time it's been done, it's just with a central organization deciding. This time we get to do something else, and we're expanding upon that. Using that transaction ordering mechanism, we can do a lot more than just payment system for criminals. We can do payment systems for non-criminals too. It's awesome.
Yeah. We can
that's my rambling.
Use the same technologies to build good.
Build good, yes. Which, I did want to ask our marketing department. There's a grammar error in there. Should be the adverb. I think build goodly, I believe. So I'll send a message over to them. I'll get that sorted out. All right, that's what we got time for today, folks. If you ever want to, ask any other questions or extremes, please don't feel hesitant to do so. Happy to answer, happy to talk, happy to engage. Yeah, we'll kind of close it out here. I need to find the little button. This one, heck yeah. So yeah, I mean, definitely appreciate you watching. If you want to learn more about Topl, you can take out your phone, scan the QR code. That'll take you to our link tree, linktr.ee/Topl_protocol. From there, you can find our Discord, our Twitter, our Twitch, our LinkedIn, our GitHub, our YouTube, everything. We've got lots of stuff on there. We've even got some Spotify playlists if you're curious about what we listen to. So yeah, I mean, that's what we got time for today, folks. Appreciate you. Tune in next time. See you later.